Yo, what is up YouTube? In this video, we're going to take a look at how we can solve this differential equation, y double prime plus 9y equals the delta function of t minus 3. So a couple of things to recall here. Definitely lean in on your equation sheet. This will be a helpful tool for you throughout the exam. And let's take a look at sort of the things we're going to do for this type of problem. So to start with, we want to take the Laplace transform of all of the parts. So right here we have y double prime. So let's take the Laplace transform of that. And that is equal to s squared y minus s times f of 0 minus f prime of 0. And this is on the equation sheet right up here, s squared times, and they use this f of s as the transform, and then these little f's as the function that you're transforming, or like the initial conditions. So that's what we get for this. And for f of 0, we're given -1. And that's s squared times y. And then f prime of 0 is y prime is 0, so we don't have to worry about that. And then let's take the Laplace transform of y, and that's simply equal to big Y. And then finally, the Laplace transform of this delta function. And remember, this is like sort of like you hit the system with like an impulse that spikes up really quick and goes away. So this one also has a transform that's on the equation sheet. Delta of t minus t naught equals e to the negative st naught. So yeah. So this is this delta function of t minus 3. So our t naught is 3. And that equals e to the negative 3s. So putting everything together in this equation, we know what the Laplace transform of y double prime is. We get s squared y minus s times -1 plus 9 times y, big Y right here, equals e to the negative 3s. So now let's rearrange in terms of big Y. So first off, this becomes a positive, and then we're going to subtract over s on both sides. We get s squared plus 9, I'm factoring out the terms in front of y, equals e to the negative 3s minus s. So y equals e to the negative 3s over s squared plus 9 minus s over s squared plus 9. Awesome. Now all we have to do to conclude this is find the Laplace inverse of big Y, and that's equal to y of t, which we're trying to solve for. So let's take a look at that. So we have the Laplace inverse of e to the negative 3s over s squared plus 9 minus s over s squared plus 9. Something we can pick out really quickly is this looks like the form cosine of kt. And I'll show you that on the equation sheet. S over s squared plus k squared. And so what is k going to be? K equals 3 because 3 squared equals 9. So that's where we're getting the k from. So minus cosine of 3t is part of our solution. So now we have minus cosine of 3t plus the Laplace inverse of e to the negative 3s. And what I'm going to do is actually pull the e to the negative 3s out like this and have 1 over s squared plus 9. And now this form looks like k over s squared plus k squared, but this k up here is wrong. So And we also have to account for this part. So let's start off by accounting for this part. We have the e to the negative 3s times this 1 over s squared plus 9. This is another item that's on the equation sheet. You just got to look a little bit. It's this form right here, e to the negative as times the transform of something. And that goes over to this, where it's the step function of t minus a times f evaluated at t minus a. So right away, this is equal to negative cosine of 3t plus, and we pull out the Heaviside step function because of the transform of this, t minus 3. It's not like pulling out, it's more like starting the solution, and then this is the Laplace transform of negative 1 over s squared plus 9. But for this Laplace transform, let's evaluate as t goes to t minus a. And the reason we're doing that is because when we're going backwards from this to this, we're evaluating f at t minus a. So that's an important step, and if you miss that, you're going to miss the question. So make sure you're remembering that. And now this form, let's try and work with this thing a little bit. The Laplace transform of the inverse Laplace transform of 1 over s squared plus 9. So for this to resemble this form, we need k, the top term, to be equal to 3. So what we can do is multiply by a cleverly disguised 1, 3 over 3, then pull out 1/3. We're just pulling out the term we don't want in there. And then this ends up being 3 over s squared plus 9. And remember, we're evaluating as t goes to t minus a. So in total, negative cosine of 3t plus the Heaviside step function of t minus 3 times 1/3 sine of, and k right here, k equals 3, so 3t. But t goes to t minus a, so let's replace this with a t minus a, where a is equal to 3. And that's our final answer. We're going to rearrange it. So it's t minus 3, this Heaviside step function t minus 3 times 1/3 sine of 3 times t minus 3, and then subtract cosine of 3t, and that's our final answer. So as you can see, I was kind of being explicit about each of the steps that I was taking just for the sake of teaching this concept. But when you're taking this on the test, you might be shortcutting a couple of the factors, like not rewriting so many of the terms so many times, just separating the Laplace transform and doing the parts that you're trying to focus on one at a time. And like this factoring thing, once you have enough practice at it, it becomes second nature. And if this were like a number like 4 or something, you just pull that out with it, and then you get 4/3 out front. But it's not 4 in this problem. So yeah, hope that helps for this next upcoming exam.